Good morning. I'm Vikhyat Katti of the Department of Civil Engineering of Gopte Institute of Technology. I'm here to present to you the contents and some details of the course Introduction to Civil Engineering. The name of the course is Introduction to Civil Engineering, and the course code is 22 ESC 141 or 241, depending on which semester you take this course. And the course type is Engineering Science course. So let us dive into the course and look at its contents. So this is the syllabus, detailed syllabus of this course, Introduction to Civil Engineering. It is a 40-hour course and it is mainly a theory course. Now, why should you study this course? So the learning objectives of this course are the students will be learning specializations of civil engineering. So civil engineering is a vast field. There are various branches, and students will get to know what each specialization of civil engineering, or what a specialized engineer in civil engineering does. Students will also be introduced to concepts of sustainable development, sustainable infrastructure, smart cities, green infrastructure, and related topics. Then we also introduce concepts of engineering mechanics to the students. The concepts involve forces, equilibrium of forces, resultant of forces. Students will also be solving problems, application problems on these. So let us look at the detailed syllabus. So, as I said, in the beginning, you'll be learning about different streams of civil engineering. So, Unit 1 and Unit 2 will include all the topics related to these, where you'll be introduced to what is civil engineering, what are the different domains of civil engineering, then what are the basic materials of construction in civil engineering, and such. You'll also be introduced to what are the structural elements of a building, like beams, columns, foundations, all of these. Then we move on to what is sustainable development. These days, development has to happen, but with sustainability in mind. So, sustainable development is very important, and that is what will be introduced to the students, along with smart city concept and other related topics. Then we introduce engineering mechanics and the force system, forces, what is the resultant of a force, what is equilibrium of a force, and related theorems. We go through that, principles and theorems. And in the end, we also introduce to the students some of the cross-sectional properties which are important in engineering, and these are namely centroid and moment of inertia. So this is the entire syllabus of this course. Now, ultimately, a student who's opting for this course must ask this question as to what is in this course for me? What will I gain after taking this course? So this course will be opted by the students of non-civil engineering background. So students of all the branches that are not civil engineering will be opting for this course. So that will include IT branches and core branches. So what is in it for the non-IT branches, like let us say mechanical, aeronautical? So for these branches, engineering mechanics forms one of the basic subjects for them. So mechanical engineering students and aeronautical engineering students will be taking this course to get introduced to engineering mechanics, the basics of engineering mechanics, like what is a force, what is a moment, what is a couple, what is the resultant of a force system, what does it mean when we say that a force system is in equilibrium, or when a body is in equilibrium. So all of these things they will be studying, the students who opt for this course. And this is needed in aeronautical engineering and mechanical engineering. So this forms the basis for these students. Along with that, these cross-sectional properties are also equally important, because in again mechanical engineering, when you're designing components of a machine, or aeronautical engineering students when they are designing parts of an aircraft and such, they will need these properties. They will have to calculate these properties or look for methods to compute these values of these properties. So these form, I would say, the building block, the basic building block for mechanical and aeronautical engineering students. Now for the IT branches, what is in the course for them? So as you know, all the engineering branches are now moving towards a digital domain. So everything is being done digitally these days. To begin with, all the designs, modeling of the structures, everything is nowadays happening digitally. uh, Concepts like building information modeling and digital construction are coming up, and all these applications that are made for civil engineering will be developed by IT students. So this forms a basic introduction for these students to gain domain knowledge in this course. And once you have domain knowledge, building any app, building any application for civil engineering becomes that much more easy. You and Building an app is only valuable when it has an application, and most of the apps that are built will have application in one or the other field. And to build that app, having domain knowledge is very much important. So having said that, that is what this course has to offer, and I recommend students who are interested in this course to register for this, because the seats are obviously limited. Now let us also look at uh, what are the outcomes. What will the students be able to do once they take this course? They'll obviously be able to understand different disciplines of civil engineering. Then what are the infrastructure requirement for sustainable development? Then compute resultant and equilibrium of force systems. They'll be able to locate the centroid of plane and built up sections, and compute the moment of inertia of plane and built up sections, which we have already discussed. So that is about this course. The evaluation of this course will involve two internal assessments. Then there'll be assignments, and then course seminar. So totally the internal assessment, continuous internal evaluation will be out of 100 marks. So I hope to see many students register for this course, and I hope to see you all in class. Thank you.
Hello, good morning all. I am Snehal Kulkarni from Department of Electronics and Communication Engineering. I am here to introduce the course, that is ESC, that is Emerging Science Courses, Introduction to Electronics Engineering, with the course code 22 ESC 243. This is the vision and mission of our department. Vision is the Electronics and Communication Engineering department shall impart quality technical education and entrepreneurship skills to develop creative individuals to face challenging global scenario. Mission of our department is to augment the national talent pool with electronics and communication engineers having all encompassing technical knowledge, principled practices, and nationalistic outlook. Significance of electronics engineers. Going to see the compliances which we are using, electronic compliances. We can see as day to day the compliance are becoming okay, binary number system, logic gates, realization of full adder, half adder. Finally we have unit 5, that is transducers and sensors. This is a wide area actually. Okay, sensors and transducers are very important topics. So this is fully theoretical but very useful topic for you. And then after learning the course, the students will be able to explain the construction types and characteristics of PN junction, explain op-amp, explain basic concepts of digital electronic circuit components, working and principle of transducers, sensors. This is a easy subject. Okay, it is not complicated and tough. It is easy subject, and we'll be having interaction sessions also. We'll be having learning based activities. So it will be very interesting to learn this subject because it has theory as well as problems. So it is not completely theoretical, not completely mathematical. So there is a balance of both. These are our few esteemed recruiters like Samsung, Tejas Networks, Herman, KPIT, Falabella. I look forward for more number of students to register for our course. For any information or any help, okay, we are there for you. Dr. Bhagyashri Pandurangi ma'am, myself Snehal Kulkarni and Abhishek Deshmukh sir. We are providing our email IDs or any, you can meet us personally also. So this, I look forward for more and more students to register for our course. Okay, thank you.
ಮಾಡ್ತಾರೆ ಯಾರು ಇರಲಿಲ್ಲ ಅಂತಂದು ಮಾಡಕ್ಕೆ ನನಗೆ ಏನೋ ಗೊತ್ತಿರಲಿಲ್ಲ ಐ ಥಾಟ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಆರ್ ಸಿಟ್ಟಿಂಗ್ ಅಂಡ್ ವಿ ನೀಡ್ ಟು ಸ್ಪೀಕ್ ಇದೇನೋ ಬೇರೆನೇ ಸಿಸ್ಟಮ್
ಇದು ಲೈವ್ ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ಶೇರ್ ಮಾಡ್ತಾರೆ ಸ್ಟೂಡೆಂಟ್ಸ್
ದೆನ್
ಸಿಲೆಬಸ್ ಕಾಪಿ ಬೇಕಂತ ಏನಿಲ್ಲ
ಐ ಜಸ್ಟ್ ಸ್ಪೀಕ್ ಓಕೆ ಒಂದು ಪಿಪಿಟಿ ಅಂತ ಮಾಡ್ತೀನಿ
Start and hear. Hello students. Programming with C language has been one of the most popular subjects in engineering curriculum, and it dates back to nearly 40 to 45 years. One important thing to wonder is why are they teaching C programming in the first or second semester of engineering since a pretty long time now. Even today, and even as it was so many years back, learning a programming language is the basic way to develop aptitude for problem solving, which is the main goal of engineering. C language is a good way to start learning programming logic. Logic is the way things work, and to develop logic, we need to understand through a programming language what are the techniques available to us, what are the data structures available to us, what are the features available to us in today's programming languages, which are so many actually. We are talking about hundreds of programming languages, but the starting point seems to be programming in C language. Even today, the campus recruiters focus on students who should know one programming language in depth, and most probably that language is the C language. So learning programming is a basic necessity, be it for any branch, even if you are for mechanical engineering or the circuit branches like computer science, information science, AI/ML, any other equivalent branches, even civil engineering. All students need to learn programming languages. In that, C language, I tell you, I vouch for it because from so many years I've been teaching C language, though I know other languages also. It's a very fundamental way to enter the world of programming. The constructs, the style of programming is easy to understand. You cover topics like the basics of programming, the constants, the variables, the declarations, the kind of operators that are available. Then you slowly start building small programs using the conditional statements, branching statements, the looping constructs like the for loop, while loop. Concepts are very important. While learning these concepts, we don't rush into develop big size problems. We are interested in learning minute details of every programming statement that is written in a programming language.
whatever programs you are going to construct, you have to develop logic, you have to think about what constructs have to be used, and you have to develop a program. So the world of programming is very interesting. Learning it in a proper way is the foundation to becoming a good programmer. If you are a good programmer, if one or two languages like the C language to start with, and then later, if one or two languages like the C language to start with, and then later you also study an object-oriented language like Java or Python, you will be a complete personality in terms of developing logic and solving problems. Today, it is a time of convergence. All the branches are converging. If you see innovation and whatever technologies are being developed, whatever devices you see are a combination of all technologies. You can't be specific that this is only electrical engineering problem or this is only a mechanical engineering problem. All the devices, all the technologies seem to be a convergence of so many things together, and almost everywhere you see computer programming takes a very important position. And starting learning programming with C language forms the basis. So across after unit 2 or 3, we cover aspects like pointers, which is a very important way to manage memory, faster access to memory locations and the storage. Structures and unions are the other topics which will be covered. The curriculum is pretty standard 5-unit curriculum. And then you will be also encouraged to write on many programs which are from the campus placement point of view important and what they ask during the campus interviews. Those kind of problems will be covered in the course. So I welcome all of you to explore the world of programming through C language and take up this course to be confident in programming, which definitely this program offers. Thank you so much for listening.
ಹಾ ಸರ್ ಬರೋಬ್ಬರ.
ಏನೋ ಓಪನ್ ಮಾಡಿ ಹೇಳೋ ಏನು
ಡೌನ್ ಮಾಡಿ ಮತ್ತೆ ಸುಮ್ಮ ಓಪನ್ ಆಯ್ತು.
ಓಕೆ ಸರ್. ನಾ ಎತ್ತಾಗ ನೋಡು ಎಲ್ಲೇ
ಕೈ ಕಟ್ಸಿ ಈಗ ರಸ್ತೆ
ಅದ ಹಾಂ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ. Good morning, everyone. I am Ishwar Gowda V. Patil, so the faculty from Department of Aeronautical Engineering. So today I came for to give about the orientation class or the introductory class for the introduction to aeronautical engineering. The course code is 22 ESC 246. First thing, so we can see what is the objective of learning the students, right? So of these subjects and all. So first point is to understand the history, basics, and what are the types of aeronautics and what is the trend going on aerospace industries. So because now within the next 15 years, like CS, the aeronautical or aerospace industry is also a booming one, like transparent aircrafts and scramjet engines, UAV drones, then spacecraft, space debris. These are all the trending things which is going on with the for the next 15 years. In next one is about the basics of flight and aircraft propulsion, how it works. See, we are talking about the types of aircrafts and how it works. We have to study is that we will understand, and we will understand about the flight controls and dynamics of the aircraft, and we'll study about the systems, how it works. That is nothing but the purely avionics systems. And now after studying this, what are the outputs we will get? So we'll get what are the different industries are there in aerospace. So how to apply, how the aerospace industries will be, or openings will be there for the non aeronautical engineers. And we will learn about the aerodynamic forces, and we'll compare with the atmospheric layer conditions. That is nothing but the how the aircraft will work in the stratosphere or troposphere or anything, and how the air breathing and non air breathing works, and what is the component, and how its principle works, and all these things we'll study. And we will study about the basic of flight dynamics, aircraft performance and stability, and we will study about the system of aircraft. In the unit 1, we will study about the history of aviation. So what is the aviation history, how it starts, not only about the Indian aviation, world aviation also we will study. So how it starts, the aviation industry starts from 1903 to 2025. So how it works, how the engine development happened, how the structural development happened, how the material development happened, and how the drones will work, what is the principle behind that one. So how it works, or what are the structural members, and what are the different types of structural members, and we'll study about the helicopters. And so where we are going to give its application and all these things, so we'll study in the unit 1. In the unit 2, we'll study about the standard atmospheric conditions and Bernoulli's theorem, how the speed, how the Mach number, and what is the aerofoil. Aerofoil is nothing but the 2D of a wing, and how it works, what is the different types, how the naming will be given, what are the forces which will act in an aerofoil, how the pressure variation will occur, what is vorticity, and all these things we'll study. And also we'll study by fabrication or manufacturing of the wing. Right, we don't know what is the pressure distribution and all, so we'll go for the testing in the wind tunnel. Right, so we can study about the practical and theoretical knowledge about the wind tunnel testing, because we have the lab. Next one, in the unit 3, we'll study about the purely based upon the propulsion. So it is nothing but the aircraft power plants. That is nothing but the air breathing engines, non air breathing engines. In the air breathing engine, what are the types? What are the types of non air breathing engine? How it works? What is the principle behind that? How, what is the application? What is its efficiency? How to increase its efficiency, and all these things we'll study in the unit 3. In the unit 4, so we have studied, I told you already about the what are the different types of aircrafts, how the engine works, aerodynamics and all. So all these things we need stability. So without stability, nothing will work. So for that reason, in the 4th unit, we'll learn about the aircraft stability and control, how it works, what are the phases of flight. So what is the high lift devices, what is thrust, what is power, how the thrust and power will work, and how, what are the access systems, what is trim condition, and all these things we'll study in the 4th unit. And the 5th unit we'll study about all the aircraft systems. That is nothing but the cockpit system, navigation system, accelerometer, gyrometer, oxygen system, hydraulic system, pneumatic system, fuel system, communication system, instrument landing system, APU, auxiliary preliminary unit, fly-by-wire system, fly-by-light system, and all these things we'll study in the 5th unit. And now, see, after studying this one, so what is your output? See, simply you cannot choose a subject, right? Right, as a non-aeronautical engineer, if you are choosing the this subject, what will be the output? So basically for the non-aeronautical engineers, you have opportunities in the aviation industry, in the basically in the airports like ATC and all. All right, ground aviation engineer, fuel aviation engineer, nuclear aviation engineer, and all these things we'll get. So basically we'll go as a will you will get as a aeronautical engineer, where you can do the designing and testing, all right, of the each aeronautical component or each aircraft components. Next one, go for the flight system engineers, that you can develop the advanced flight control systems and the navigation system. Propulsion engineer, means for the designing and optimizing the both the engines and the rockets. Next one is about the researcher. You can conduct the research in the different domains. That is, aeronautical has been basically 5 different domains. That is aerodynamics, propulsion, structures, then AME, aircraft maintenance engineer, avionics, and drones. Next one is about the aircraft performance analyst. That is to perform the data to improve the aircraft efficiency and the safety. Basically, for the references, you have to refer the book called Introduction to Flight by John D. Anderson and all. Next one. So these are the CIE components of your introduction to aeronautical engineering. So IA1 and IA2 having 30 plus 30, OBA 1 and 2 10 plus 10, and course project or seminar if you are doing, that is 20. Totally out of 100, this is the split up of your component. If you have any doubt, you can contact Professor Mukta Magdum or Professor Ishwar Gowda for any clarifications. Yeah, and it is very easy subject and interesting subject. Yeah, thank you.
ಮಗನ್ ಬರ್ತಡೇ ಆತ್ರಿ ರೀಸೆಂಟ್ ಆಗಿ
ಸರ್
ಮಗನ್ ಬರ್ತಡೇ ಆತಲ್ಲ ರೀಸೆಂಟ್
ಹೌದು ಸರ್ ಮೊನ್ನೆ ಆಯ್ತು ಜಂಟು ಆಯ್ತು KG ఉంటుంది ನೆಕ್ಸ್ಟ್ 7th
ಈಗ ಯಾವ ಕ್ಲಾಸ್ ರೀ
UK ಸರ್
ಯಾವ ಸ್ಕೂಲ್ ಹಾಕಿರಿ
ಹಾ?
ಯಾವ ಸ್ಕೂಲ್ ಹಾಕಿರಿ
ಇಲ್ಲ ಸರ್
KLS ನಮ್ಮ ಮಗ ನಿಮ್ಮ ಮಗ ಆಮೇಲೆ ರಾಘವೇಂದ್ರ ಅವ್ರ 2ನೇ ಮಗಳು
ಮಗಳ ಸೇಮ್
3 ಮಂದಿ ಜನವರಿ 18 2019
ಹೌದಲ್ಲ ಓಪನ್ ಮಾಡಿ ಸರ್
ಇಲ್ಲ ಡ್ರಾಫ್ಟ್ಸ್ ಒಳಗೆ ಇಟ್ಟಿದ್ದೆ
ಇದು
ಅಲ್ಲ ಅದಾಗ್ಲಿಲ್ಲ ಅದಲ್ಲ ಅಲ್ಲ ಸೆಕೆಂಡ್ ಆಗಿ ಅದು
ಇದೆ PPT ಫಸ್ಟ್ ಇವ ಇದೆ
ಇನ್ನೂ ಮೋಸ್ಟ್ಲಿ ಮಿಸ್ ಮಾಡಿದೆ
ಹಾಂ ಸರ್ TC ಮಾಡಿರ್ತಾರೆ
ಸರ್ ESC ಸರ್ Hello, dear friends. Today I'm here to introduce about a subject named Introduction to Electrical Engineering, whose subject code is 22 ESC 242. This is all about getting to know about the electrical things. Okay, here as per the syllabus in Unit 1, we are going to study typical electrical system and power generation. Here we are going to see different types of electrical power generation like hydropower station, thermal station, solar and wind power generation using block diagram approach. And after that, here we are also going to see how the power is transmitted, generated, transmitted and distributed from generation to distribution. Using line diagram, we are going to see how it at different levels, how it is transmitted and distributed. And then after that, we are also going to see a line diagram. Using line diagram, we are going to see how the power is distributed to all the electrical appliances in a house, that is domestic wiring layout. And we are also going to see the protection devices like fuse, MCB, earthing, switches and all those things for a requirement of the domestic purpose. And we in this unit are also going to see the billing of energy. Okay, here we usually see many times the energy bill for required for the calculation, but we never understand how it is calculated. Here in this, we are going to see how much units the house has consumed, and as per that we are going to see the total, the calculation of the energy bill and safety measures to be taken for domestic purpose. This is for unit number 1. And unit 2 is about studying DC circuits and single phase AC circuits. Yeah, it starts with Ohm's law and Kirchhoff's laws, and it is most of the time it looks like basics of your second physics, which you people have studied in your second PU. But here we are going to take you to the advanced level of that. Here you are going to see series and parallel circuits, and here you are going to actually apply the KCL and KVL equations to analyze the circuit parameters. Okay, and we are also going to see single phase AC circuits. Here you will see how the single phase AC is to be generated, and the associated parameters like frequency, uh, average value, RMS value, form factor, peak factor of the AC things. And then we are also going to see how AC will behave with different parameters, with different passive elements like R, resistor, inductor, capacitor, and the combination of resistor, inductor, resistor, capacitor, and resistor, capacitor, inductor. Here we are going to see these things with the help of equations, with the help of derivations, how the current will behave with respect to the voltage. And we are going to see all these with the help of equations, phasor diagrams, and we are also going to see the real power, reactive power, and apparent power for all these combinations of passive elements. And unit 3 is all about transformers and DC motors. Transformers, here in this we are going to see how the transformer is constructed, the different parts of transformers, how it is operated, the working principle of transformer, and then we are going to see different types of transformers. We do have in our department the wooden models of these transformers. We will show you the inner parts of the transformers and what are the EMF equations on a transformer on primary side and on the secondary side, what is transformer ratio, the different losses occurring in transformer, and we are also going to calculate the efficiency of the transformer, because even though the transformer is just a mediator, it doesn't consume power, it is just a mediator from source to the load, but still there are certain losses occurring in a transformer. We are going to calculate the efficiency of the transformer, and the new parameter to you is voltage regulation, and then we are going to see the applications of transformer, where all the transformers are being used, and numericals based on the efficiency and regulation. We are going to solve them in this particular chapter. And then we have the next part of unit 3 is DC motor. Here also we are going to see the inner parts of the DC motor, the construction of the DC motor, and the basic working principle of the DC motor, and the significance of back EMF, torque equation, and different types of DC motors. Like different types are like shunt motor, series motor, and the compound motors, and different operating characteristics of these different motors. Looking at these the operating characters, we can find the application of that particular motor, and see, like it's like if it is a DC shunt motor, looking at the characteristics of that, we can actually decide this particular motor for particular application. If we see the characteristics of DC motor, we can define the particular application for that particular DC series motor. So operating characteristics of all these motors are very much important for any future applications. So this unit 3 belongs to transformers and DC motors. Unit 4 is all about three-phase AC circuits and three-phase induction motor. Three-phase AC circuits. Even though we have studied in unit 1 about single-phase AC circuits, here we are going to show you why the three-phase AC circuits are required. Advantages of three-phase AC circuits over single-phase AC circuits. Because even though we use only single phase at our domestic purpose, but most of the applications of the power are from three-phase AC circuits. So three-phase circuits are important. So here we are going to see the necessity and advantages of three-phase AC system, how the three-phase AC is being generated, definition of phase sequence, because if there are three phases, then definitely there will be some phase sequence. What is the phase sequence, and what is the balanced load? If that is a three-phase system, all the three phases are to be equally balanced, they should be symmetrical. And then the three-phase connections, these three-phase connections will be having three-phase windings. How these three-phase windings are interconnected, they are called as star and delta connection. Okay, we are going to see how the power is distributed to these three-phase systems, and we are also going to see how this three-phase is to be measured. Even though we might have heard that wattmeter is sufficient to measure the powers, okay, but to measure three-phase power, only two wattmeters can be used, and we are going to see in this particular chapter. And then we are also going to see three-phase induction motor in this particular unit. So whenever we hear three-phase induction motor, we always remember joke from Three Idiots movie, but this particular chapter will make you understand very easily about three-phase induction motor, the working principle of three-phase induction motor, how the three-phase induction motor is constructed. Because three-phase induction motors, I tell you, 95% of the industrial motors are induction motors. We may study different types of motors, but nowadays I tell you, most of the industrial applications are based on this three-phase induction motors. Okay, and so only here we are going to see how the three-phase induction motor is going to work, and internal parameters of the induction motors like slip and frequency, the rotor frequency, and all those applications of the different types of motors like squirrel cage induction motor and slip ring induction motor. And not only that, here we are also going to see the starter part of the induction motor. Induction motor, even though it is called as a self-starting induction motor, a starter is required for that. So we are going to see the necessity of starter and one or two types of starters, and a few numericals on three-phase induction motors. This is all about unit number 4. And unit number 5 is all about measuring instruments and few domestic appliances. Measuring instruments include the dynamometer type of watt meters and electronic energy meter, and CTs and PTs. Here we are going to see the operation, how the construction and working is done for the watt meter, how it actually works, and the energy meter. The energy meters are nothing but which measures the energy which you people daily see at your places, at your in your houses. Okay, we are going to see the working of these watt meters and energy meter using block diagram approach, and we are also going to see the working of current transformers and potential transformers which are used in industries. Okay, and along with that, here we are also going to see the construction and working of LED lamps. These are few domestic appliances. Okay, the day-to-day life appliances like LED lamps, ceiling fans, water heaters, and UPSs. So using block diagram approach, we are going to see the construction and working of all these domestic appliances. So this is all about the syllabus, and these are the objective of learning the course. Here students will be able to understand the fundamental concepts of electrical engineering, including circuit analysis, electrical machines like transformers, generators, induction motors and DC motors, and measuring instruments and few electrical appliances. Here it is very helpful in taking interdisciplinary projects, and it will be very helpful in understanding the EV technology. So these are the few objectives of the learning these particular courses. And prerequisites for this particular course, this prerequisites are nothing but the basics which you people have studied during your 11th and 12th standard physics. And who can opt this particular course? Except triple E branch students, all other branch students can opt this particular course. That is Aeronautical, EC, CS, IS, AIML, Mechanical and Civil branch students can opt this particular course. Thank you.
Good morning, everyone. This is Dr. Rajiv Kulkarni, and I'm the head of the Department of Chemistry and Coordinator Center for Nanoscience and Nanotechnology. I'm taking emerging technology course, that is Introduction to Nanotechnology. That's 22 ETC 15, that's 25C now. So what is nanotechnology? Nano is a buzzword nowadays. Whatever the field you talk about, nano has entered into that field. You talk about the electric vehicles, you talk about the sensors, you talk about the memory devices, you talk about quantum LEDs, displays. What is nano? Nano is a Greek word which means dwarf, something extremely small. I'll ask you a question. Can you charge your mobile within a fraction of a second? Yes, you can do it with supercapacitors. So normal capacitors you have seen, parallel plate capacitors, you coat it with nanomaterials and use electrolytes, proper electrolytes and separator. You can develop a electrical double layer capacitor which can store up to 10,000 to 20,000 farads of charge. I mean 10,000 farad is 10,000 into 96,000 farad. That much charge you can store. Okay, and
Can you recharge your smartphone battery once a year? If you recharge today, the next recharge will be next year itself. Yes, it's also possible using nanotechnology. Okay. Another question: why the floor needs more space than grains? Okay, when you powder them, surface area to volume ratio increases like anything. Okay, so surface area, the main thing in nanotechnology, is huge. So in electronics, we talk about memory devices, um, right? Semiconductors, okay, CMOS, complementary metal oxide semiconductors, okay, field emission transistors, single electron transistors. They all rely on nanotechnology. Everything is has reached nano. Okay, VLSI, what do you talk about? It's nanotechnology based. So do you know what is the technology behind QLED TV? It's nanotechnology only, right? So we'll uh, it has got a lot of applications. Say in energy, batteries, supercapacitors, fuel cells, and solar cells. Quantum dot sensitized solar cells and dye sensitized solar cells. In medicines to cure cancer and all. The nanobiotechnology. So almost all devices have reached the nanoscale. A chip nowadays is 3 nanometer chip. Okay, optical engineering. Okay, nanotechnologies. Defense and security. We use nanotechnology. Bioengineering, cosmetics. Okay, SPF 50. You might have heard. Okay, sun protection factors in sunscreens and all. You can use nanotechnology to develop that cosmetics. Um, Nanofabrics. Okay, name any field. Okay, it has nanotechnology has reached. Okay. um, so in your studies, okay, in your the syllabus we have introduction to nanomaterials. So basically, what are nanomaterials? We'll be discussing what are nanomaterials, how they are synthesized. There are various methods of synthesis. Either you can synthesize nanomaterials by bottom up approach or top down approach. Bottom approach means from chemistry or the wet chemistry thing, okay, joining the atoms or ions by together to form clusters and then nanomaterials. Or another way is just take a bulk material and hammer it. This is a physical method, top down approach, physical or mechanical approach. When you powder it, you get nanomaterials. Okay, so both have got advantages and disadvantages, right? So you will be studying, right, sol gel process, okay, of bottom approach. Okay, and you will be studying laser ablation. You'll be studying Silar technique of coating thin films. You'll be studying uh, many right, synthetic methods like chemical reduction and all those things. Okay, precipitation, chemical reduction, combustion, solution combustion technique. Okay, so you can prepare nanomaterials either by top down approach or bottom approach. Okay, so you should know what is nanomaterial. Okay, so nanomaterials, there are three dimensional, two dimensional, one dimensional nanomaterials and zero dimensional materials. The properties change drastically when you go to bulk to nano, because you are confining the electron, and surface area to volume ratio increases like anything. Because of that, the properties change. Okay, gold is yellow, okay, when it is bulk, but you can make it different colored gold when you make it nano. So nanoparticles, right, conductors may become semiconductors, and semiconductors may become insulators at nanoscale. So how to see the nanomaterials? Nanomaterials you cannot see because they are so small. Okay, it's beyond our limit of vision. Okay, optical vision. Okay, you cannot see nanomaterials, but you can characterize using electron microscopes, probe microscopes, or different techniques. We have spectroscopic techniques we can use to characterize nanomaterials. So we'll be studying all those. What are electron microscope? What is scanning electron microscope? What is transmission electron microscope? What is X-ray diffraction? Okay, and what is UV and UV visible spectroscopy and infrared spectroscopy? How it is used in characterization of nanomaterials. Anything less than 250 nanometers we cannot differentiate or resolve. Okay, whatever the resolving power of any microscope is up to 250 nanometers. So, these characterization techniques you'll study in this. And third chapter, the third unit deals with carbon-based materials. So super hard materials like graphene, single layer of graphite is graphene. Graphene technology is used in many batteries, fuel cells, and many other applications. Supercapacitor applications, graphene, carbon nanotubes, right, carbon diamonds, nano diamonds, fullerenes. Okay, so all these materials you study, their characteristics, how they are synthesized, okay, and what are their applications. In the fourth unit, we talk about nanotechnology in energy storage and conversion. Energy storage is basically uh, right, batteries. Okay, we talk about lithium ion batteries or sodium ion batteries. Okay, so how it is stored, right, hydrogen is stored, for example. Conversion, right, solar cells, dye sensitized solar cells, quantum dot sensitized solar cells, okay, which use nanomaterials to convert light energy into electrical energy. Okay, there are some problems with silicon based technology because it's very costly compared to the nanotechnology, right, solar cells. But still we have not reached up to that. Okay, that conversion efficiency, but still we can develop these things in our laboratories. We have labs. Okay, we can come and do the laboratory activities. We can synthesize nanomaterials. We can write papers. You can do small projects on this nanotechnology. Okay, you can write, um, develop a solar cell using nanotechnology, dye sensitized solar cell or quantum dot sensitized solar cell, and you can present it in a conference or something that we can think of. Small projects can be done in nanotechnology. And right, um, what are the applications of nanotechnology? It has got wide application, be it in water treatment. Nanotechnology is used in your AC filters. We use nanotechnology in displays. We use nanotechnology. In semiconductors, we use nanotechnology chips. Okay, integrated chips. Okay, circuits. And it's used in right, super hydrophobic coatings, nano paints. Okay, right. So you name any application, nanotechnology has reached. Biotechnology. Okay, nanotechnology has reached display devices. Nanotechnology has reached sensors. Okay, sensors, different types of sensors. Electronics engineering can, okay, it's useful, very useful for electronics, mechanical, and civil students. Okay, so especially electronics, you talk about FETs, field emission transistors. Okay, SCTs, single electron transistors, sensors, display devices, memory devices, and all electrical applications like supercapacitor. Uh, so name any. Okay, right. One in cosmetic industry, in civil, nano cement. Okay, nano steel. Okay, in mechanical we have um, nano fluids for different application, cutting fluids and all. Nano composites are used in various applications in automobiles. So there are many things you can study and you can do projects here. And at the end of the course, you should understand the fundamentals of nanoscience, describe what is nanomaterial, characterize nanomaterial. It's an introductory course, but still you can do projects. And right, so many things can be done here. Okay, thank you. Thank you very much. If you are interested, you can take this course. Okay, I'll be the uh, teacher for this course. Thank you. Okay.
Good morning, students. Myself, Dr. Uma Pallur from Civil Engineering Department. I'm going to deal with the green building ETC course, that is emerging technology course. So this is with a code of ETC 22 ETC 25B. So this particular subject has the prerequisite of uh, environmental studies as a prerequisite. Here we are going to study the syllabus as green building materials in the unit 1. So the green building materials deals with sustainable type of construction. So we are doing nowadays we are going for conventional construction type. So when we are introducing green building materials, it is going to give a good effect on environment, and the bad impact is going to be reduced. So this different materials we are going to study in green building materials of unit 1. And in case of unit 2, environmental friendly and cost effective building technologies. So nowadays, as we are going to see, different technologies are going to be seen in the construction field. So the environmental friendly and cost effective building technologies are dealt in unit 2. And coming for unit 3, the global warming. So this is one of the burning topic nowadays. So we the construction engineers, by using different materials, we are producing some greenhouse gases. So to reduce this, what sustainable construction can be utilized, and how the global warming can be reduced, and what type of sustainable constructions can be carried out to reduce the global warming, that we are going to see in unit 3. And in case of unit 4, green buildings and rating system. So there are a rating system for our construction works, irrespective of whether it is an industry or commercial building or our residential buildings or any mega structures. There are different types of rating systems which are going to give the rating to the building with respect to green and sustainable technology, where the usage of green and sustainable technology. In case of unit 5, we are going to see the utility of solar energy in buildings. So the maximum amount of solar energy can be utilized in our building construction, so that the energy which we are using, electrical energy, can be reduced. So what is this? This all was related to the syllabus of the green building. So what is this green building? It is a structure that is designed to be environmentally responsible and resource efficient throughout its life cycle. Green buildings are also known as sustainable or high performance buildings. So these buildings are constructed using the green materials. The 5 principles of green building that we are going to see is livable communities, energy efficiency, indoor air quality, resource conservation, and water conservation. So now, after knowing the 5 principles, let's look at the 4 basic elements in green building that we are interested to deal. That is, the first one is in increasing energy efficiency. How the energy efficiency can be increased in our structures, that we are going to see. Materials that are going to be selected for building our home. So that materials should provide the aim for sustainable construction. Increasing the efficiency of water usage both in and outside our home. So that we are going to see as a basic element. And improving air quality, which improves the health and productivity of our family, is the last basic element of our green buildings. So although new technologies are constantly being developed to complement current practices in creating greener structures, the common objective of green building is to reduce the overall impact of the built environment on human health and the natural environment by efficiently using energy, water, and other resources. Therefore, for this type of construction, we are going to see that the tangible benefits that may not be easily recognizable to tenants or visitors, but through sustainable design, construction, and operations, green buildings are reducing carbon emissions, energy, and waste, conserving water, prioritizing safer materials, and lowering our exposure to toxins. So, coming for this entire course, you have just a brief introduction was given. So, coming for the job opportunities, if you opt for this particular subject is that you can go for as a site in charge operation, sustainability consultant, area manager with respect to domestic marketing network, enterprise sales manager, construction site manager, building inspector, and green building analyst. So this was the overall outcome of our green building etc course. So the students who can opt is, except civil engineering students, all other branches can opt for this particular subject. Thank you.
Yes, started. Good morning, everyone. So today I am going to brief you about one ETC course that is floated by Department of Civil Engineering. The course code is Introduction to Sustainable Engineering. It is one of the ETC courses floated for the second semester students. So coming to the learning objectives of this particular subject is, it is one of the essential subject in present scenario. You might have come across the sustainable word, that is the new buzzing word in the industry. Uh, Most of the products which are manufactured or most of the products which are designed, they are need to be oriented towards the sustainability. One or the other way, the companies they have to justify that it is a sustainable projects or the products. In your many of the items what you purchase nowadays in the market, you can see that recycle, reuse kind of a thing. So these are all the parts of the sustainability. Now in this subject we are going through the basics about that particular sustainability. So the objectives goes like this: to familiarize the students to the area of sustainability and the concept of sustainability engineering, to enable the students to understandings of the principles and the framework of the sustainable engineering. So after going through the introduction part, so we are going to introduce you people what are the principles on which the sustainability works, okay, and we will apply some engineering touch on that to provide our students with an understanding of life cycle assessment tool in a sustainable engineering. So when we say that one product is manufactured by a sustainable approach or the sustainable way, then who is going to quantify that and how to quantify that one, the measurable aspects. So that will be done through the life cycle assessment tools. There are many tools which are available in the market, and there are researchers which are working rigorously, so they can quantify. So how much sustainability means, how much carbon reduction has happened, how much economy is achieved, how much recycled materials are used in manufacturing of this product. You might recall that recently one of the cell phone that is launched, it was completely manufactured with one of the recycled aluminum parts. Okay, to provide students the understanding of integration of sustainability with the design. So design is a separate part, and we have to get that sustainability approach in this designing. So all the conventional methods of designing will have to be modified, and we have to incorporate the sustainable approach in designing of these new products or the products which are going to be designed. So module 1, the title says the sustainable development and role of engineers. So here we will introduce you to the definitions of sustainable development, and the SDGs, they are called as sustainable development goals. And in 2015, the Paris, one of the conclave took place, and most of the countries in the world, they have signed that treaty, and it is famously known as Paris Agreement. So whatever the developments, whatever the projects they are going to initiate in their respective countries, they should be oriented towards these sustainable development goals. There are nearly 17 sustainable development goals as such. Sustainable development and the engineering profession. So how best the engineers can contribute? I am not saying that sustainability is only limited to engineering profession. In what you say, that in any profession you can take out the sustainability is there. So just for example, agriculture is one of the professions, so where our farmers are practicing sustainable approach from centuries together. Okay, but how best an engineer can put them in a engineering manner and make them more optimistic, means the optimization should take place, and so that those practices can be aligned in a proper way, and that engineering touch can be given to those practices. So that's why the engineering with the sustainability is a very talk of the town now. Sustainable engineering concepts. So there are many concepts on which sustainable engineering works. So famously it is a factor 4 and factor 10. So these things will be taught in detail during the class sessions. Life cycle thinking and circular economy. So how the economy works and how the life cycle thinking, everything should be dealt in detail with some of the case studies. So coming to the second module talks about sustainable engineering and concepts, principles, and the framework. So here we will introduce about the green economy, low carbon economy, and eco-efficiency. So there are some countries which are depending upon some of the manufacturing countries, and these manufacturing countries are having a lot of workforce, and this workforce will be employed in the factories, and the factories are going to produce a lot of products. So that produced products should contribute by emitting the low carbon into the atmosphere, so that the greenhouse gas emissions can be reduced. So how these things can be attained, and how the green economy, in the sense, a great example is green economy is a digital transactions what we people are doing right now in the India. So it is a part of green economy, one of the best examples. So where the currency printing is reduced, so that uh, all the subsidiary products which are required, including dyeing, including manufacturing of the paper, including the printing, wrapping up of those bundles and transporting them to the different banks, and then putting in into the ATMs and all those things, it will consume a lot of energy. So what if you make a digital transaction, the same amount of money is transited through the digital platforms, all these expenditures can be saved, and thus you people are moving towards a sustainable approach. That means all this whatever the projects are coming, they are all part of the sustainable approach. And then triple bottom line, guiding principles of sustainable engineering, frameworks of sustainable engineering, all these things are a little bit technical part, how the sustainability approach is considered. Then tools for assessment. So if something is done, then we need to have a proper quantification of that. Someone has to come and evaluate that one. So there are many tools available to measure the sustainability. One is environmental management system and environmental impact assessment. Environmental management system is mandatory for all the companies which are going to create some manufacturing uh, process, or else you can say big factories, to be coming in nearby vicinity, then they have to go through this all procedures. They have to produce a detailed report on environmental impact assessment. So it will be taught in detail during the course of the subject. So moving on to the next module, that is called as fundamentals of life cycle assessment. So life cycle assessment is one of the very important aspects in terms of engineering, or as a part of sustainable engineering. So here you will be introduced what is life cycle assessment and what it is called and how it will be framed with respect to the goals and what is the future scope of this. So every product is having some life cycle. So that life cycle should be assessed properly, and a life cycle inventory, life cycle impact assessment, interpretation of the results and presentation of the results. So these are the four major pillars of this LCA. In short we call them as LCA, steps of LCA. And then it comes to the limitations. What are the present limitations of LCA and what are the strengths of LCA? So if any system is developed, of course it will be having some advantages and disadvantages. So we have to discuss about the advantages as well as disadvantages, and we have to come out those limitations, and we have to justify the works what we are going to project. Next, fourth module talks about the environmental life cycle costing, social life cycle assessment, and life cycle sustainability assessment. So here we will be introducing with respect with life cycle costing. So if, say for example, if any one product is manufactured right from its cradle, that means right from when it comes out of the factory till it will be disposed, so that is the entire period of the product. So cradle to grave we call them. So there are many stages in this. So what is the total cost consumed? Sometimes what will happen after the certain usage hours, you will be taking that particular product for repair and maintenance. So there also you people are putting some of the cost, so that all things will cumulatively add up to that particular product and be quantitatively called as a life cycle costing. So if a product is consuming a lot of cost during its life cycle, then it is not a good product. Okay. So then social life cycle assessment, life cycle sustainability. So these things will be introduced. Then LCA applications in engineering. So life cycle assessment, how this can be applied in the engineering field. See, there are many manufacturing units in and around us, in and around the Belgium, in and around India, in India. So each product is manufactured, and we can apply the LCA concept to each product, and we can quantify how much carbon emitted, how much energy consumed, whether it is going to be sustainable product or not. All these things we can quantify with some of the tools and technology. So we can certify that product that this is a sustainable product. So like this, that's why this brandings, but whatever the product you purchase, you just go through the specifications or else the highlights of that particular products. So they are going to highlight all these things, that this product is manufactured with the recycled materials like this. So building and built environment, chemical and chemical production, food and agriculture. So applications of this life cycle assessment is applied for the buildings, construction of the buildings, built environment, the ecosystem, the chemical or the dyeing factories, or the chemical productions of the food and agriculture aspects. So everywhere it has an application. Then comes environmental economics. So you have heard about environmental studies, you have heard about the economics, but what is environmental economics? This is a new concept which all the countries are aligning towards. So you have to develop your economy, you have to give more jobs, you have to produce more what you say that your market base and all those things, but not at the cost of environmental compromisation. That means you have to degrade the environment on one side and you go on expanding your industrial developments and all those things on the other side. No, it should not happen. It should be like a complete ecosystem, so where everything will be coexisting without damaging the existing nature. How best you can get the product out of that. So that is called as environmental economics. In short, I am just explaining. So then here the market-based incentives will be taken, that is market economic instruments for sustainability, command and control versus economic instruments. All these things will be dealt in detail. And coming on to the last module here, integrated sustainability. Integrating the sustainability in engineering design. So as I told, there are age-old technologies which we are following to produce some of the goods. So we have to come out of that old method of producing some of the goods, and we have to incorporate the sustainable approaches. So how that integration can be done? So of course the engineers will be the frontline, what you say that people who will be guiding these principles to the manufacturers. So here the problem solving, conventional sustainable engineering design process, design for life cycle life guidelines and strategies measuring sustainability, sustainable design through sustainable procurement criteria, case studies, how the case studies means some of the products are aligned towards this designing with respect to sustainable approach, how they have overcome the difficulties, so how you can generalize this particular concepts for the other products. All these things we can have a deep discussion in this particular module. Design process, the sustainable design process, sustainable design, uh, product design in electronics engineering. So electronics engineering also a field of manufacturing sector, so there also we can apply the sustainable design process. So this is all the brief introduction about the sustainable engineering subject. So I hope you will be having a very good learning if you opt for this particular subject. This is a very essential subject nowadays. Wherever we go for manufacturing sector or else a consumer side, so we will be aligned or we will be worried about whether am I damaging the environment because of manufacturing of this particular food or what. So if it is not, then you will feel a little bit good that you have purchased a good product which does not um, harm the environment or any ecosystem. So it is manufactured with recycled materials or it is manufactured with some sustainable techniques and something, right? So this is what we people are going to discuss in coming semester in this particular subject. If you have any queries, you can reach out to us. So have a good day. Thank you.
Yes.
Good morning. My name is Good morning. My name is Gurraj D. Gokak. I'll be introducing you to the renewable energy sources, that is 22 ETC 25E. Okay, I'm working as assistant professor in the mechanical department of KLSGIT since 2008. Okay, so what is the highlights of this course? So this deals with the alternate energy sources and which presents a possible solution for the energy crisis. I hope you know what is meant for the energy crisis. Just recall any of the day when load shedding, due to the load shedding or the maintenance, even for a 1 hour the electricity is not there or energy is not there, the whole day collapses. Okay, so what would be the case when the whole of the energy will be finished? Okay, so that is the energy crisis, and before that what we need to act is the possible solutions. Then what we are doing is we are going to take the analyze each source of the energy in the light of the EEE. E stands for the energy, economy and environmental aspects, okay? And for the sustainable development. You may be heard this name of the sustainable development. It's something like that. What is our need should not be affected the needs of the tomorrow's generation. That is called as a sustainable development. We are satisfying our needs without affecting the coming days generations need. Okay, then what are the salient features of the RES, that is renewable energy sources? Is nothing but first one is a comprehensive introduction, means what is the energy scenario in the world, in the India and the Karnataka. Okay, then what are the demand and the supply, what is the problem with each of the things that we are going to take. Then in the next one we'll go for the technological insights of the each sources, that is starting with the solar, wind, tidal, OTC, that is the ocean thermal energy technology, ocean thermal energy conversion, then biomass, then the green energy. In each of the case we will be discussing that what will be the energy input and what is the energy output, what are the hurdles, what are the advantages, what are the disadvantages, or in the simple words we are going to have the strength, weakness and opportunity as well as the threat for the each particular source. Please try to understand all these sources of are surely having no effect on the environment, that is the pollution free, but at the same time these energy sources are the free, agree, but at the same time we have got a one hindrance that the equipment is not free, and the equipment whatever the costs are there, those things we are going to analyze. And we have got say about 20 to 30% of the numericals in the solar, wind as well as the tidal. Okay, then we are going for the economical and the environmental aspects, that with the use of this one, how it can be a better way for the next generation. Okay, and these are the divided into the 5 units. In the first unit we have got the introduction. In second one we have got the solar, that is solar thermal as well as the solar non-thermal. Then the third one we have got the wind as well as the biomass. Then fourth one we have got the tidal and OTC, and the fifth one is dedicated to the green energy. Coming to the books recommended, or what we have got in our library, so these are the books. The books are in sufficient numbers, okay, in our library. So first book is surely the non-conventional energy sources by GD Rai, that is by Khanna Publishers. So we have got around 100 books in our library, and that will be our basic textbook for this course. The next one is non-conventional energy sources by B.H. Khan, Macro Hill Publications. Then typically for the solar photovoltaic technology and systems, it is Chetan Kumar Solanki by PHI. Then last one is the solar energy, which is dedicated to the solar energy only, by SP Sukhatme and JK Naik by the Macro Hill, other TMH publications. So all these books are available in a good numbers. Then next one, coming to the post course prospectus. So first one we have got the higher education. So there is a one center of the technology for alternatives for the rural areas at IIT Bombay, where the students of the any department can pursue the higher education, maybe the MTech or PhD. The next one, center of the energy studies by NIT Hamirpur. And please note it, although the subject seems to be very much mechanical, but it is useful for the most of the branches. So to name it, we have got the career opportunity for the electrical engineering. It will be solar PV systems, wind turbine generators, smart grids, and the battery storage systems. For mechanical engineering, it is the design, manufacturing, the maintenance of the renewable energy equipments. Then civil engineers, infrastructure development for renewable energy systems. Then computer science and the IT, that is the data analytics, IoT and AI for the renewable energy optimization. And last one, not the least, but the electronics and communications, we have got the supervisory control, instrumentation, and the data acquisition of the various systems of the renewable energies. Okay, thank you.
Again, 7 minutes.
Yes,
7 sir. 10 minutes. 5 minutes.
sorry sir, हो सर पुढे मध्ये
Same.
Scan.
Start ಮಾಡ್ಬಿಡಿ.
ಪಾಸ್ ಆಗಿದೆ
ಪಾಸ್ ಮಾಡಿ ಸರ್ ಲೈವ್ ಕಾಸಾಗಿ
ಇದ್ರಾಗ ಡೈರೆಕ್ಟ್ ಇದೆ
ಯೂಟ್ಯೂಬ್
ಡೈರೆಕ್ಟ್ ಮತ್ತೆ ನೀವು ಎಡಿಟ್ ಮಾಡಂಗಿಲ್ಲ
ಅದೇ ಮಾಡ್ಬೇಕಂತಲ್ಲ.
Good morning to one and all. Today I am going to present to you the subject of Introduction to Communication Systems. My name is Professor Girdhar S. Sudi, working as Assistant Professor in the Department of ENC Engineering. Since our subject is communication subject, let us see what is the significance of communication in our life. So communication plays a very important role in our life, as all of you know. In fact, we can say that without communication there is no life.
because in everyday life we use communication in one form or the other form. As we all know, hardly any day in our life passes wherein we don't use our mobile phones for communication, internet, or emails, and watch TV for information sharing and such things. Okay, so communication plays a pivotal role in our daily life. In fact, it is used for information sharing, teaching learning process, building relationships and friendships. It is also used in trade and business. So let us see the overview of this subject. This is a second semester subject where the type of the course is Emerging Technologies course, or ETC in short. It is a 3-credit course. That means 3 lecture hours will be there per week. No tutorials or practicals are attached to this subject. Total contact hours are going to be 40 hours per semester, and internal marks will be for 100, and semester end exam marks will be for 100. Okay, so during the course we are going to do some interesting activities also, like open book assignment and course project, wherein you can learn the theoretical concepts in a hands-on way. So looking at the syllabus of this subject, first of all, the prerequisites for this subject are not very stringent, in the sense PUC, physics and mathematics is more than sufficient for learning this subject. So there are 5 units in this subject. Unit 1 deals with various types of signals and analog modulation techniques. Unit 2 deals with digital communication techniques, which are somewhat advanced, more advanced than analog modulation techniques. Unit 3 deals with satellite and radar communication techniques. Unit 4 deals with cellular communication, and Unit 5 deals with wireless communication protocols like Bluetooth, Zigbee, NFC, and many other techniques, wireless communication techniques. So this course offers an insight into very exciting communication technologies like radio communication, television communication, telephone communication, mobile communication, radar communication, satellite communication, computer communication, and networks. So in short, we can say that this is a very exciting subject where you get to learn all these exciting technologies, communication technologies. So this course will help you to aspire for jobs in the sectors or in the companies as mentioned here, like Nokia, Sony, Samsung, Cisco, etc. Okay, where you can hope to join as a telecom engineer, system or network administrator, research and development engineer, software development engineer, etc. So there are these types of exciting job opportunities in this field, communication field. Okay. So I hope this subject will offer you very interesting learning experience in this field of electronic communication, and I hope all of you will opt for this elective subject called Introduction to Communication Systems 22 ETC 25. Thank you very much.
Next, yours actually. Also also actually more the Europe so ನಿನ್ನೆ 6 minutes 6 minutes
Gorilla, very electricity.
Thank you. Yes, sir. Yes.
ये है ना, ये अभी मुझे माइक्रोफोन लगाना पड़ेगा। तो कैमरा ऐसे नहीं सुनेगा ना कैमरा। हाँ चलिए, वो पूछता हूँ पहले उनको। सर ಕೇಳಿಸ್ತಿದ್ರಿ? हेलो वाइस हाँ सर ಕೇಳಿಸ್ತಿದ್ರಿ? माइक्रोफोन लगाने की जरूरत नहीं ना? स्क्रीन शेयर ಮಾಡಲಿ? हाँ, PPT is there, PPT is there. Okay, sir, PPT on ಮಾಡಬೇಕಾ? नहीं जी, बैठो 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 बैठो। ये रहा वो, अरे ये नहीं, ये तो ये कौन सा है? हाँ ये पहले ये सेटिंग करना पड़ेगा। सर स्क्रीन शेयर कर रहा हूँ मैं, ये प्रेजेंट नाउ, ये प्रेजेंट नाउ करेक्ट। विंडो शेयर द विंडो। हाँ इसका वो शेयर सर दिख रहा है? ओके, फुल स्क्रीन करना है या फिर क्या? हाँ दिख रहा है ना? हेलो सर, स्टार्ट करता हूँ मैं।
हाँ सर, स्टार्ट सर।
Okay, so I'm Dr. Vivek Tiwari, and today I will be trying to explain you about the subject called as Smart Materials and Systems, which is an emerging technology courses for you all. So the title name for this project, for this subject is Smart Materials and Systems. The code is 22 ETC 25A, and it is a type of ETC, that is emerging technology courses. And this is my description. I belong to the mechanical engineering department. So coming to the subject wise, this subject is completely theoretical. There is no numericals as such present in this subject, and it is very easy to understand and gain good marks in the examination. The subject is being divided into 5 units. So the first unit is emerging materials, wherein the different type of materials we will be trying to explain you all, and we'll also be trying to see some of the important recent emerging materials like nanomaterials or aerofoil material. Such type of metals will be, and even shape memorialize. This will be the things which we'll be discussing in the chapter number 1. Coming to the chapter number 2, we'll be discussing about the prefabricated building components. For example, if I tell about a building which is there in Dubai, that is Burj Khalifa, is also an example of this prefabricated building itself. So there are such numerous examples of buildings which are being prefabricated at different places, and then it is being brought at the site of construction. There are certain advantages related to it, so we will be discussing about that in the second unit. Coming to the third unit, we'll be discussing about the smart materials. So we know that there are different type of materials, but there are some unique type of materials which are smart enough, and of course they're not so intelligent also, but they're smart enough to do or respond to the changes which comes up in the environment. So some such materials are also called as sensors and actuators, which are used widely in a number of places. So the third unit is related to the study of different type of sensors and actuators actually. Coming to the fourth unit, we have BIM and IBMS, which stands for Building Information Management and Integrated Building Management Systems, which are nowadays being widely used in construction of different type of modern type of flats, etc. So you might have come across different flats having this safety precautions like cameras, fire safeties. All those things are being nowadays incorporated by using these softwares called as BIM and IBMS. So we'll be learning about that in the fourth unit. Coming to the unit number 5, it is about 3D printing. So you know that 3D printing is one of the important technologies which has revolutionized the manufacturing industry. So we know that what is 2D printing. So in this chapter, we will be particularly discussing about the 3D printing, that is 3-dimensional printing. So if you see the overall chapters, the first chapter is related to mechanical, The second chapter is related to civil. The third chapter is related to electronics. Fourth chapter is again related to civil, and fifth unit is related to all the branches of engineering. So here we can see that this subject is a multidisciplinary subject which will help any branch students. So the next topic or the next slide is like this. Here in this slide, I'm trying to show you the course outcomes of this subject and some of the applications of the subject what we will be trying to learn. The first image what you can see is a composite material. Nowadays, the Dreamliner aeroplane are having around 60 to 70% of its parts made up of composites, which is a part of unit number 1, which we'll be learning. Sensors. So you can see that this is a car spoiler or the rear wing of a car, which is incorporated with n number of sensors and actuators. So this is also an example which comes under the smart meters chapter. So the one prefabricated building which I just show you all, that is this one. It is completely prefabricated, Burj Khalifa. So it's being made at other place and being brought and positioned at the site of construction. So this is about the 3D printing. So you can see that a nozzle is there and it's printing an object. So this is the fifth unit which we'll be learning. And an interesting fact about this 3D printing is in Bangalore, if you come across, there is a post office which is completely made out of 3D printing, concrete 3D printing. So such kind of interesting things we'll be learning in this chapter subject. And of course, the subject is completely theoretical. So all of you can do well. And I hope to see you all in the subject. So thank you so much. सर स्टॉप कर दीजिए.
सी ओके थैंक यू सर.
यस.
यस सर हो गया सर. यस सर मस्त यस यस ठीक है सर मैं अभी मैं बोल दूँ. थैंक यू सर.
Good afternoon, students. Myself, Dr. Sudhakar CJ. I am here to give the counseling about the subject Introduction to Internet of Things, and this particular subject will be offered by both electrical and CS department, and it will be handled by Dr. Rudresh Magdum. And this course code is 22 ETC 15H. In the second sem, it will be 25H, and it is a 3 credit course. And the main course objectives of this particular subject is understand about the fundamentals of Internet of Things and its building blocks along with their characteristics. Means the first objective is to understand what exactly is the Internet of Things and all the components of the architecture. And the second, the objective is understand the recent application domains of IoT in everyday life. Means application of IoT, where all we can use. That is the second objective. And the third objective is gain insights about the current trends of associated IoT technologies and IoT analytics. Which basically from the IoT, what all associated technologies and analytics are the business are running. That is the current trends with respect to that. These are the main objectives of this subject. And coming to the content wise, in the module 1, we are going to discuss about the basics of networking. So all the different network types and layered network models, everything means network, whatever it will be connected to the IoT. So those networking we are going to discuss in the first module. And also the emergence of IoT means evolution. What are the different generations and how the IoT got evolved over years. So that we are going to discuss, and the networking components. So all the basic things, that is, we can call it as introduction to IoT. We are going to study in the module 1, and in the module 2 we are going to discuss about the sensors and actuators. Basically, the IoT means Internet of Things, means internet will be connected to the things means it will be microcontroller chips, and it can be sensors, actuators, whatever, the wherever we want to do the automation, that part will be called as a things. And to do this automation, basically we will be making use of sensors and actuators. So that is there in the module 2, that is the sensors, introduction to sensors and the types of sensors, characteristics of sensors. And basically we are going to study about the working principle of all the different types of sensors, and also the actuators. Basically it will be the relays, motors, all the moving components will be called as actuators. So actuator types, working principles, and the characteristics, these all we are going to discuss in the module 2. And coming to the module 3, this is basically the topologies, that is the IoT processing topologies. Topologies means how we are going to interconnect all the nodes means the individual things, how it will be interconnected, and also the data formats, then the uh, device design, and the selection considerations. All this we are going to discuss in the module 3. Basically, the how we are going to interconnect, that is whether we are going to interconnect in a star topology or the mesh topology. So what are the challenges with respect to this, how we should select the topology, means perfect topology for a perfect project. Okay, all this we are going to discuss in the module 3. And coming to the module 4, associated IoT technologies and the case studies, we are going to discuss. Associated technologies means uh, after sensing the data and after storing the data, so what all we can do it, and what all associated technologies are there to assess that data and analyze that data. All those it comes in the associated IoT technologies, especially the cloud computing, so virtualization and the service level agreement, and the sensor as a service. So all these things means after data has been stored, after storing the data, how we are going to compute that data or analyze the data. So this comes under the associated IoT technologies. And then in the module 4 second part, so the IoT case studies will be starting. So in this, first is the agricultural IoT, and the case studies means it is the application part. So how we can implement the IoT in the agricultural field. So and the use cases will be discussed in this. And module 5 is a continuation of module 4. Again here, vehicular IoT means in the transportation, especially transportation industry, how the IoT can be implemented, and the architectures and few case studies with respect to that. And also similarly in the healthcare IoT, means in the healthcare industry, how the IoT can be implemented, and architecture. So of the different case studies of healthcare examples. And then in the last, IoT analytics. IoT analytics means how to analyze the data, which all the tools are available, and uh, related to that. And even the machine learning comes under the IoT analytics. So all this comes under the module 5. So this is about briefing of the contents of the particular subject, and this will be handled by Dr. Rudresh Magdum. Thank you.
Slides ಮಾಡಿ. Sir, I'll start speaking. Okay. Good morning, students. My name is Professor Veena Kangalkar. I am from Computer Science and Engineering Department, okay, which is located in the IT block 3rd floor. I'm going to give you an introductory session on the PLC subject, that is Introduction to Web Programming. Now, PLC stands for your Programming a Language course. This is going to be a 2-credit subject where you'll be having 2 hours where we are going to discuss the concepts and 2 hours where you'll be practically implementing whatever we have discussed during the classes. Okay. Now, the course code for this subject is 22 PLC 25A for the even semester. That now you'll be having this code, and for all it is 22 PLC 15A. Moving forward, I'll just give you an overview of the syllabus. Now, web programming is a really interesting subject for the students who have no programming knowledge at all. Okay, so there are no prerequisites required for this. The prerequisites would be you should have used a computer. That is the minimum requirement that could be used for the subject. The first unit is regarding the traditional HTML and XHTML, where you'll get to know what basically is HTML, how did web programming come into picture, and how XHTML came into picture. Why was XHTML introduced, that is extensive hypertext markup language. Moving on towards the second unit where we'll be learning today's HTML, that is HTML5. Now, HTML basically is standing for hypertext markup language, because in web we make use of markup language, which is also known as a scripting language. So unit 2, you'll be seeing the structure, you'll be seeing the tags that are used in HTML5. You'll be building simple examples, simple web pages, okay, how you're going to represent your content in a particular structure, that you'll be doing in unit 2. HTML basically forms the structure of your web page, okay. So that is what you will learn throughout learning HTML. Now, coming to the next unit, that is cascading style sheets, okay, popularly known as CSS, which is very interesting one. Now, you could see this on my screen, you know, the overview of the syllabus is coming in purple color. Then I'm having 5 boxes, okay, for which the border is invisible. You can see that, and there is a color that is a background color, red color, and then text color is yellow. I can do all this using CSS. So basically, it highlights your web page. It makes your page decorative. Okay, we can have many options that we can use to change our web page or make it look more eye pleasing using CSS. So we'll learn more about it when we actually start implementing in the classes. Okay. Now, moving on to the unit 4, using CSS, you'll learn how to create a table, how to insert an image, how to create links that you have been using, you know, whenever you surf web. That time you'll get some links, how you click on them and you are moving on to the next page. All that we can create here using CSS and HTML. Okay. And then finally in unit 5 we'll have an introduction to JavaScript. So in your syllabus we have a very little introduction to JavaScript, but as always we do is we try to cover more and more JavaScript so the students get an idea about it. Now, like how I've told you what HTML does, it forms a structure. CSS, you know, gives you eye pleasing effect by making decorations to your pages. Similarly, JavaScript is like the main event that is associated with HTML and CSS. JavaScript works on the functioning. Okay, it works on the functioning of your web page. Like whenever you log into any website, it will ask you for a sign in page. So when you submit, there is action taking place, right? That is done by JavaScript. Okay, so that you will be seeing in the 5th unit. Now, why we need to learn web programming? You might have heard a very popular term, students, that is full stack development, that is happening nowadays. Now, what do you mean by full stack development? Full stack development or a full stack developer is a person who knows front end as well as back end. Now, what do you mean by front end? These three elements, your HTML, CSS, and JavaScript, together they help in forming the front end. And back end, again you are having Node.js, many other databases are there. Okay, using them like SQL, MongoDB, using them you form the backend connectivity. So together it is what together front end and backend together is a full stack development. Okay, and you have a lot of scope here now for web programming. So that's why I feel everybody should know what web programming. If anybody wants to have a career change, you can take a start here. Okay, now again, more on to why one should go for web programming. Market demands, e-commerce growth, all the websites that you're developing, it's using web, right? Then you have job roles in web programming like front-end developer. That's what I told you. You deal with your HTML, CSS, JavaScript. You have back-end developer. That is, we are managing the server-side logics, the databases, and how we are implementing the integration of applications. That is a third one, that is full stack developer, that is combining both front end and back end. Then you also have someone known as web designer, where he'll be designing the layouts of the websites, nothing with the functioning, only designing part. And then you have DevOps engineer, again a very popular job role. Now, finally, I'll get to the course outcomes. Definitely, after learning this subject, you'll know what is HTML. You'll know what is XHTML, what is CSS, what is JavaScript. Apart from that, students, you'll get the confidence of learning and creating your own web pages. That is very important. Okay, where you can create your own web pages, you can design your own web pages. Okay, that confidence I'll give you. And finally, you will learn about JavaScript. Okay, I'm also sharing the scheme of CI. Okay, you have two labs. Actually, the scheme is changed now. You have IA, which is divided into two, and the marks are 30. Okay, and your lab component is 40. Together, it will become 100 marks. Well, thank you, students. I hope you will take this subject, and welcome to web programming.
ಅದಕ್ಕೆ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಮತ್ತೆ
ಸರ್ ಇದು ಶೇರ್ ಮಾಡಿ ಎಸ್ಕೇಪ್ ಇದು ಮಾಡಲಿ
ಕಟ್ ಮಾಡಿ
ಮೈಕ್ ಆನ್ Good afternoon, students. I am taking this elective, Introduction to Electric Vehicles. The code is 22 ETC 25J. This mainly deals with the electric vehicles, which is a new topic now, and it is of 300 credit, and the code is 22 etc 25J. Electric vehicles is the new trend now, and you can see here one of the battery electric vehicle where the batteries are stored in the vehicle, and this will be one of our unit. You can also see the hybrid electric vehicle here, where the when you apply brake, the electric vehicle stores energy in the battery. So this type of vehicles, we call it as hybrid electric vehicles, where mainly IC engines are used, but I am using battery for storing the energy while applying brake. Also, you can see that in the plug-in hybrid electric vehicle, I have a fuel tank as well as charging point. You can see here the charging point as well as fuel filler here. So with this, I can use the vehicle whenever there is no charge in the battery. I can use the fuel. But when in the cities, for example, if I don't want emissions, I can use the electric motor. So the motors will be one of the unit, that will be means second unit. So you can see here the syllabus is prerequisite is basic physics. You need to know only just basic physics, and you can see all the EV history, electric vehicles in India, advantages, all those things in unit 1. In the unit 2, you will see all those motors which are required in the electric vehicle. In the unit 3, you have all the architectures, the configuration of mainly 4 types, what I have already explained. One is battery electric vehicle, another is hybrid electric vehicle, another is plug-in hybrid electric vehicle. We also fourth one is the fuel cell electric vehicle, where I am using hydrogen as a fuel or any other fuel cells. So the fourth unit here is comprising of the batteries, different types of batteries, voltage rating of batteries, and the specific energy, specific power, and how I actually choose a battery for electric vehicle. All these things are covered in the unit 4. We have a newly built lab in the department, the ground floor. Students can visit the lab whenever they have a doubt or whenever they need to explore. Unit 5 is with respect to battery management system, where I have different types of charging points, charging types, type 1, type 2, etc. And the battery management system, how actually the system of charging will be so will be studied in the unit 5. So these are the textbooks which are soft copy I have. I can provide the soft copy of these 2 textbooks which is mentioned in the syllabus. So main why we need electric vehicle is we have a lot of pollution which need to be controlled. For example, India need to cut the carbon dioxide, particulate matter, all those emissions which are coming out of petrol or diesel vehicles. We have a target by the government, 33% to 35% reduction in the emissions by compared to 2005 in 2030. That is the target. So climate change is one of the thing which is mainly driving this. You also have a lot of employment opportunity or entrepreneurship opportunities with respect to charging stations, etc. So any branch students can opt for this, because all this, for example, infrastructure is lacking in India. Also, we have a lot of renewable energy invested by the government. So to achieve 40% of electricity generation by renewable energy is one of the target for India. So because of that whatever is renewable energy which is generated using wind, solar, etc., that can be utilized to charge the batteries. Also, due to a lot of urbanization, you have a lot of emissions in the cities. So this also need to be cut. And then the due to the fixed cost and the critical element of achieving total cost of ownership will be less in the EVs. So this will be compared to the internal combustion engines. You can see some of the vehicles are cheaper, like the electric scooters. And also you need to advancements in the battery technology, like a lot of research is going on with the help like lithium ion batteries, new types of batteries, and how actually battery management system is getting the data from the battery charging stations, etc. This is another new development in the research also. We also need to have energy security for India because we are dependent on other countries for petrol, diesel, etc. So this is another reason for EVs. So that is thank you for listening to me. So welcome to this open elective. Pendrive sign up. ತಮ್ಮ ಹೆಸರು
ಸೊ ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಲೈವ್ ನೋಡ್ತಾರೆ ಅವರು ಅಂದ್ರೆ ಲೈವ್ ಲಿಂಕ್ ಇದೆ ಅಲ್ಲಿ ಲಿಂಕ್ ಆಮೇಲೆ ಶೇರ್ ಮಾಡ್ತಾರೆ ಅವರು ಆಮೇಲೆ ನೋಡ್ಬೋದು ಸರ್ ಎಲ್ಲಿಲ್ಲ ಸರ್ ಎಲ್ಲಿಲ್ಲ ಸರ್
Okay. So good afternoon. I'll be giving introduction to Python programming, a subject that is a PLC subject for your first year of engineering. Subject code is 22 PLC 15B for the first semester, and for the second semester it is 22 PLC 25B. Uh, I'll just first start with my introduction. My name is Dr. Ganesh Chate, Associate Professor in the Department of Mechanical Engineering. So I'll first explain you why to learn Python programming. As you know that programming is a most essential part of any software. So as an engineer, why you should learn this Python? It is a very simple and easy to learn programming language, and it is very beginner friendly programming, what we generally call it as, because syntax are itself the self-explanatory, and it is very versatile, used in web development, data analysis, artificial intelligence, and many other applications. It is high in demand because it is used in almost all the fields nowadays, and if you know Python programming, you are valued across all the industries. So even the users of this Python programming are uh, more, so the community is large, the people who make use of this particular Python programming. So what is Python programming? It is a high level interpreted programming language, so used to develop the apps, or develop the websites and all these particular applications. So the creator or the inventor is Guido van Rossum, who invented this in 1991. So the key features are: it is interpreted language, it is dynamically typed, object oriented, open source programming. Real world applications, as I explained, it is used for web development, data science and machine learning, automation, game development, mobile app development. These are only few of the applications that I have listed. There are many other applications as well. The career opportunities in after learning this Python will be the data scientist, the software developer, AI ML engineer, web developer, cyber security analyst, etc. The syllabus is something like this. Basically, this course is an integrated course. That is, you are going to have 2 hours theory in a week and 2 hours lab. So unit one will give you brief introduction about what is problem solving, why programming is required, what are the different types of programming languages, and for any programming we have something called as an algorithm, flowchart, and the pseudocodes, which we are going to explain in detail. After this, in unit number 2, we are going to study about the basic introduction of Python programming. What is Python programming? What are its salient features? And we generally make use of ideally, to execute these Python programs for your syllabus. About that, we are going to discuss in brief. Then we are going to express about variables, assignments, keywords, data types, and operators that we use it in Python, and simple programs just like finding the area of a circle or volume of a cuboid. Like that, we are going to do some small programs in order to make you uh, uh, well versed with the basics of programming language. In unit number 3, we are going to study about decision making, that is if else, all this type. And after that, we are also going to uh, teach you about iterations or looping. And in unit number 5, we are going to study about lists, functions, and string formatting. So here we are going to make use of if different elements we want to store which are heterogeneous in nature, then how to deal with them, and if the program is too large, how to convert them into modules. That is what we come across something called as functions. And also we are going to deal with the string formats, because most of the times we make use of strings. Apart from this, in unit number 5 we have tuples and dictionaries. So we are going to solve a simple exercises on tuples and dictionaries, and what is the difference between a list, tuple, and a dictionary. That also we are going to deal it in this particular unit number 5. Okay, and in lab we are going to have totally 13 programs. The first 2 programs are related to a software called as Flogorithm, where we are going to draw the flowchart using a software, and we are going to check the outputs. Remaining programs, that is from program number 3 to 13, these are all related to coding, that is Python programming. Whatever we have from unit 2 to unit 5, the entire thing will be covered in the lab. Thank you. Stop streaming. Stop recording.
Stay here. Stay here.
ಈ ಥರ ಸೈಬರ್ ರೂಮ್ ನಂದವನ್ನ ಇಲ್ಲಲ್ಲ?
Yes, sir.
ಇಲ್ಲ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.
I have two files. You have pen drive? Yes. आगे Yeah. Some saga has color chali. Massage करें तो color. Massage. छोटा है क्या बड़ा? ಇಲ್ಲಿ ನೋಡ್ಬೇಕು ಇದು ಕರ್ಸರ್ ಈ ಕಡೆ ಹೋಗ್ಬೋದು. ಒಂದು ಸೆಕೆಂಡ್. ನೀವೆಲ್ಲ ಓಪನ್ ಮಾಡ್ಕೊಡ್ರಿ, ಓಪನ್ ಆದ್ಮೇಲೆ ನಂಗೆ ಹೇಳಿ.
ಇದೆ
ನಿಮ್ ಅಲ್ಲ ನೀವೇನ್ PPT ಅದ್ನ ಏನ್ ತಂದಿಲ್ಲ.
PPT ತಂದಿಲ್ಲಲ್ಲ.
ಮತ್ತೆ ನೀವು ಹಂಗೆ ಹೇಳ್ತೀರಿ, ನಿಮ್ಗೆಲ್ಲ ಬರ್ತದ?
ಹಂಗೆ PPT ಮಾಡಿಲ್ಲ ನಾವು ಅದಕ್ಕೆ.
ಅಲ್ಲ ನೀವು ಹೆಂಗ್ ಹೇಳ್ತೀರ ಅದನ್ನ?
ಸಿಲೆಬಸ್ ಬೇಕಾ? ಕೊಡ್ತೀನಿ.
ನನಗ್ ಗೊತ್ತಿಲ್ಲ. ಕೆಲವು ಜನ PPT ತಂದಾರೆ, ಕೆಲವು ಜನ ಸಿಲೆಬಸ್ ಕಾಪಿ.
ಸಿಲೆಬಸ್ ಓಕೆ, ಸಿಲೆಬಸ್ ತೆಗಿತೀನಿ.
ಇಲ್ಲ ಮಾಡ್ತೀನಿ ನೋಡಿ, ನಾನು ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀನಿ. ಹಾಂ ಹಾಂ ಹಾಂ, ಮತ್ತೆ ಇದು ಸ್ಟಾರ್ಟ್ ರೆಕಾರ್ಡಿಂಗ್ ಮಾಡಿದೆ. ಹಾಂ ಹಾಂ, ಅದು ಸ್ಟಾಪ್ ರೆಕಾರ್ಡಿಂಗ್ ಆಗೈತದ. ಹಾಂ ಹಾಂ, ಓಕೆ 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 ಓಕೆ.
ಸ್ಟಾಪ್ ಮಾಡಿ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ಇದಾಗುತ್ತೆ ಫಿಟ್ಟಿಂಗ್. ಇದು ಒಂದೇ ಉಳಿತಿ. ಅದೇನ್ ಕೇಳ್ಬೇಕು ಸರಿ ಇಲ್ಲ, ಕೊಡ್ತಾರೆ ಏನೋ ಬಂದಿದ್ದ ಅವ ಫೋನ್ ಮಾಡಲ್ಲ, ಫೋನ್ ಮಾಡ, ಯಾಕಂದ್ರೆ ಅವ್ರಿಗೆ ಫೋನ್ ಮಾಡಲ್ಲ.
ನಾನು ನಿನ್ನೆ ಫೋನ್ ಮಾಡಿದ್ದೀನಿ.
ಸರ್
ಟ್ರೈ ಮಾಡಿ ಸರ್.
ಆಯ್ತು, ಇನ್ನು ಮಾಡಿ ಸ್ಟಾರ್ಟ್ ರೆಕಾರ್ಡಿಂಗ್. ಕರ್ಸರ್ ಈ ಕಡೆ ಇಟ್ಕೊಂಡು.
So good afternoon. So today I'll going to give the introduction session on introduction to mechanical engineering. So that is IME, and it is an ESC course. So for coming to the mechanical engineers or any engineering background, okay, so everyone should know what is the mechanical engineering. Okay, so in our day-to-day life. So for this, here we can see the first unit is a introduction. Okay, so introduction means where the mechanical energy will fit, and later we can see the importance of the mechanical engineering even in the energy sector. So while coming to the energy sector, so one is an tidal power plant and the solar power plant, and simply we can call it the non-conventional energy sources. Okay, so next later here we can see the unit number 2. So in unit number 2, so it is completely on the machine tool operation. Okay, so for example, if we take the drilling operation. Okay, so in the drilling operation, so even there uh, we should know the importance of the mechanical engineering. So not only that one, so even if we go to any the industries like the automotive industry, uh, for example the car manufacturing. So in the car manufacturing, so it requires some operations. Okay, so that here we can see one is an lathe operation. Okay, so next is an the drilling. Okay, next is an the milling. Okay, so everything it will going to cover in the unit number 2. So that is a machine tool operation. So one is a lathe, so one is a drilling, and one more is the milling operation. Okay, later, so here we can see the introduction to advanced manufacturing system. So here in the machine tool, okay, so it is only the lathe. Okay, later, okay, so we'll go to see the advanced. Advanced is nothing but see one is the CNC, okay, or NC. So one is the computer pneumatic control by using some codes. Okay, so or by using the robots. Correct. So whatever it will helps in the automotive sector. So next is an unit number 3. So it is completely on the internal combustion engine. Okay, and as well as the EV. So that is electrical, and one more is the hybrid vehicles. So everyone know. So it is if you take car, if you take bike, or any the automotive sector. So completely it is we can call it the internal combustion engine. So here you're going to know the basic principles of the 4-stroke petrol engine as well as the 4-stroke diesel engine. Okay, further, so we're going to see the future mobility. So right now, so whatever we can see the internal combustion engine. So while coming to bikes or the motors or cars, everything. So now this IC engine, okay, it is completely replaced by the EVs, okay, or the hybrid vehicles. So in unit 3, so clearly we're going to know the what is the internal combustion engine and the future mobility. So next the unit number 4. So it is on the engineering materials, because while coming to our day-to-day life, okay, so we are using the materials. For example, if you take the kitchen. So in the kitchen, so we are using one is the silver, aluminium, okay, as well as the steel. Okay, so here in details, okay, so you're going to learn so what is the ferrous and the non-ferrous materials. So that we're going to call it as the engineering materials. So later, so the joining process. Okay, so later can say the joining process. In the joining process, okay, just I'll give one small example. Okay, so if you take the similar materials, or we can say the dissimilar materials, so there we can see the welding process. Okay, so or else if you see the circuits, so in the circuits, so we can see the soldering. So in unit number 4, it will tells the details about the joining process. Okay, so next the unit number 5. So unit number 5, it is completely on uh, the mechatronics and the robotics. Okay, so and we know uh, the combination of the mechanical as well as the electronics. Okay, the combination of the mechanical and electronics, so that we're going to call it as the mechatronics. So in this mechatronics, okay, so you're going to learn in details so on now, so what is the open loop as well as the closed loop, and later you can see the robots. So one is the robot configuration. So one is the cylindrical, Cartesian, and the spherical or polar the coordinates. And along with this, okay, so we can see uh, the Internet of Things. Okay, so this whatever the IoT, okay, means by using the Internet of Things. Okay, so we're going to including in the mechanical background. So while coming to this ESC, so that is Introduction to Mechanical Engineering. So it will tells the overall view. Okay, means the what is the importance of mechanical engineering. Okay, in the industry sectors. Thank you.